Hello, we're going to look at the chemical properties of oxygen, reaction of metals and nonmetals with oxygen. Yeah, this deals with the chemical properties of oxygen, which includes the reaction of metals and nonmetals. We are going, okay. Oxygen is a very reactive nonmetal. Oxygen is a nonmetal. Many elements react with oxygen through burning to form a group of compounds called the oxides. Yeah. Burning and combustion is the reaction of oxygen with an element substances. Reaction in which substances is added oxygen is called oxidation reaction. If you ever told what is oxidation reaction, this is a reaction in which a substance in which oxygen is added. Burning, combustion are example of oxidation reaction. Most nonmetals burn in oxygen to form an oxide which is in solution, dissolved in water, is acidic in nature. Some nonmetals burn in oxygen to form an oxide which in solution. That means when you dissolve it in water, you get a neutral solution. And a neutral solution has a pH of 0. All metals burn in oxygen air to form an oxide which is in solution. When dissolved in air, it's either basic in nature. Okay, basic and alkaline are the same. Alkalinity and basicity. We start with reaction of metals with oxygen. As you all know, examples of metal are magnesium, sodium, potassium, blood, and the rest. For magnesium, we are going to take 2 centimeters of magnesium ribbon. Use a tool from into a flame. First, you have to scratch on the surface of the ribbon to remove its oxide. Then you use a pair of tongue and introduce it into a Bunsen burner flame. Remove it when it catches fire and observe. You will see that it burns with a lilac flame. Yeah, there is some color you will notice. After burning, take now what you have obtained and put in a beaker containing 5 centimeters of water. Then place the solution using a litmus paper, either red or blue. You see it's either acidic or basic. What you observe is that when the ribbon is burnt in air, it burns with a bright blinding flame in air, forming a white solid or ash or powder. Evanescence bubbles or pungent smell of urine. Then blue litmus paper remains blue. Then red litmus paper turns blue. Okay, for me, the easier way to identify this if it's acidic or basic is where we that is B, R, and A. For B, if the blue litmus paper turns red, that means the solution is acidic. And for this one, blue litmus paper remain blue, and then red litmus paper turns blue. That means this basic. Yeah, form a basic solution. When a ribbon is burnt in pure oxygen, it burns faster with a very bright blinding flame. Pure oxygen form a white solid, no effervescence, no pungent smell of urine. Okay, anything that you hear that it has a pungent smell of urine, it has something to do with ammonia. Okay, for this one, we were burning with air but not pure. That's why it has the pungent smell of urine. There is a presence of slight ammonia, but when you burn it in pure oxygen, you won't find the pungent smell. Yeah, you won't find it will only be, yeah. Then the blue litmus paper remain blue, red litmus paper turns blue. That means this is an acidic solution. since the blue litmus paper has no turned red, that yeah, so it's basic or alkaline. Magnesium burns in air, reducing and asks it to react with both oxygen and nitrogen to form magnesium oxide and magnesium nitride. Both magnesium oxide and magnesium nitride are white solid ash powder. Here is the chemical equation for the reaction of magnesium with oxygen to create magnesium oxide. When we add magnesium plus nitrogen, we will get a magnesium nitride. IDE, the end of the nitride, the oxide. I guess you'll find it at one of these chapters that the IDE symbolizes that it's two compounds, the magnesium and the nitrogen. Magnesium oxide dissolved in water to form a basic or alkaline solution of magnesium hydride. We add magnesium oxide plus water to give you magnesium hydroxide, which is alkaline. And we have said when it's alkaline, then Bra, translate quickly. Bra, B-R-A, said that blue litmus paper turns red, and A stands for acidic. Magnesium nitride dissolved in water to form a basic alkaline solution of magnesium hydroxide and production an ammonia gas. Ammonia is also an alkaline basic that has a pungent smell of urine. Yeah, that's why I told you when you hear anything has a pungent smell of urine with presence of ammonia. Yeah, magnesium nitride plus water will give you magnesium hydroxide with ammonia gas. Next, we are going to burn sodium. Sodium is a metal, just as magnesium, as we have seen. So carefully cut a small piece of sodium. Use a deflagrating spoon to introduce it into a Bunsen burner flame. Remove it when it catches flame. Then put it in a beaker and add 20 centimeter cube of water. That is not you taste if it's acidic or basic using the litmus paper. Keep it using the pure oxygen. Yeah. When burnt in air, sodium burns with a yellow flame. You have to know the colors. Yeah. The sodium burns with a yellow flame in air and form a black solid. For magnesium, it forms a white solid. But for sodium, it forms a black solid. Blue litmus paper remains blue and red litmus paper turns blue. That means it's still basic. Hope you are noting it. Magnesium is basic, sodium is also basic. When burnt in pure oxygen, sodium burns faster with a golden yellow flame. Okay, let's go for yellow with pure oxygen to form a yellow solid. Effervescence of oxygen, this gas production which relies a glowing skin. This is paper remain blue in the air. Sodium burns in air to form a black sodium oxide, which is sodium plus oxygen with sodium oxide, which is black solid. Sodium oxide dissolved in water to form a basic or alkaline solution of sodium hydroxide. So sodium oxide, which is Na42, reason why there is a 2 in sodium is because sodium has a valency of 1, oxygen has a valency of 2. So it interchanges to form sodium oxide. Yeah. Sodium peroxide dissolved in water to form a basic alkaline solution of sodium hydride. Oxygen is used, that's why it rekindles a glowing skin. We go to calcium. Calcium is also a metal. Yeah, calcium is a metal. We repeat the procedure as the other ones. You take it in a thong, burn in a Bunsen burner, then the remaining what you've obtained put in water and test the solution using a litmus paper. Calcium burns in oxygen with difficulty producing a less pink red flame. Oxygen form a white solid. This is magnesium, so we have two white solid, magnesium and calcium oxide. Magnesium oxide is white, calcium oxide is white. Blue litmus paper remains blue, red litmus paper turns red. Calcium burns in air forming a white calcium oxide. This calcium plus oxygen will give you calcium oxide. Small amount of oxide dissolves in water. The others all were dissolving, but this one is a small amount of it dissolved in water to form a basic solution. The sodium, magnesium, calcium. Both are alkaline. Hope you are noting the difference. We have a white solid in magnesium oxide and calcium oxide, and a black solid in sodium oxide. We are going to iron. Iron is also a metal. Yeah, you repeat the processes where you pick the iron with a phone, burn what you've obtained, add water, then test with a litmus paper. Iron burns with a golden orange flame and oxygen forming a brown solid. Blue litmus paper remains blue, red litmus paper remains turns faint blue. That makes this also alkaline. It's still a solid, but you have to know the difference now here. You need to change the flame color, which is golden orange or orange flame. And then the solid is brown. And the brown solid is iron oxide. Hope you following. Ions burns in air to form an iron 3 oxide. Iron plus oxygen to form iron 3 oxide. Very small amount of iron 3 oxide dissolved in water. We have calcium and iron, which are slightly soluble in water. What we are noting, they are oxides are slightly soluble in water, and they form a hydroxide. If you take an oxide of a metal, add water, you get an hydroxide. We have iron 3 hydroxide, like the others, calcium hydroxide, magnesium hydroxide, sodium hydroxide. That's because we took each oxide, like magnesium oxide plus water, you get an hydroxide of the metal. Now we are going to copper. Copper is still a metal. You repeat the processes of burning it using a pair of tongs. Don't use your hand, you'll get burnt. So use the tongs and a Bunsen burner flame. Take what you've obtained, the solid, mix it with water, then test with the litmus paper. Yeah, copper tan shaving or burns with less difficulty, producing a green flame. Now the color. We have the green flame and oxygen and a brown solid. So we have two brown solids, the iron and copper. Blue litmus paper remain blue, less than faint blue. Copper plus oxygen will form copper 2 oxide, then copper plus oxygen and oxygen. In reaction, a very small amount of copper 2 oxide dissolved in water. We have another. We have calcium, iron, and copper, which are slightly soluble in water. As I said, when you take an oxide of a metal, when I say an oxide of a metal, it's like copper oxide, sodium oxide, and you add water. You produce an hydroxide of the metal. When I say hydroxide of a metal, it's like copper 2 hydroxide. Don't know if you're getting what I'm saying, but copper 2 yeah. A reaction with non-metals. We are done with the reaction with metals. Now let's start with the reaction of non-metals. Carbon is a non-metal. Valency of 4. And the point is predictable. We will understand about the predictable later on. Yeah, for this one again we repeat the processes. You pick it, burn it in a Bunsen burner using a flame. What you obtain, put it in a beaker and swirl to dissolve. Then take the solution using the litmus paper. Carbon burns in air faster in oxygen with blue non-super and smoky flame, forming carbon dioxide gas. When you take carbon plus oxygen, complete combustion will give you carbon dioxide gas in excess, and carbon dioxide is CO2. Carbon burns in limited supply of oxygen. This one was in excess oxygen, we are going to the limited supply, that means oxygen is less. When you take carbon dioxide gas, when you take carbon burns with limited supply of oxygen, you will obtain carbon monoxide, which is CO2. That one was the other one was CO2 with excess supply of oxygen. Limited supply of oxygen will get carbon monoxide, which is CO. Carbon plus oxygen and limited supply will get carbon dioxide. Carbon dioxide gas dissolves in water to form a weak acidic solution, which is carbonic acid. If you take carbon dioxide, you add water, you get carbonic acid, which is a weak acid. Yeah, we're going to sulfur. Sulfur is a non-metal. Yeah, you take this in a deflagrating spoon, place sulfur powder on a Bunsen burner flame, observe the color change. Yeah. We are going to use the pure oxygen. Sulfur burns in air and faster in oxygen with a blue non-toothy flame, just as carbon, to form sulfur 4 oxide gas. Sulfur plus oxygen will give you sulfur 4 oxide gas in excess air. That means in excess oxygen. Then when you burn sulfur, you take sulfur 4 oxide gas, you dissolve in water, you'll get the sulfuric acid. Yeah. If you take the gases, oxide of a oxide of a non-metal, that is sulfur, carbon. Yeah, and you add water, you'll get an acid. For instance, here we have sulfuric acid. We had carboric for acid. Yeah, that's where we have acid. This thing has gone too fast. Sorry. Yeah, well, it's sulfur. Yeah, we have phosphorus. Phosphorus is a non-metal also. Just repeat the procedure as the others. Yeah, phosphorus is stored in water. Why is phosphorus stored in water? Because when you expose phosphorus in air, it catches fire or burn faster in oxygen, with a yellow flame producing a dense white acidic fumes of phosphorus 4 oxide. When you take the phosphorus 4 oxide and dissolve in water, you get phosphoric 5 acid, which is a weak acid. Yeah, and then now we are done with the reactivity of metals. Now we'll end there. We'll meet later on the reactivity series for competition or we can complete it. Yeah. Oxygen. The reactivity series is listed elements of metal according to their affinity for oxygen. Some metals have higher affinity for oxygen than others. A metal with high affinity for oxygen is placed higher on the top of the less affinity. Yeah, we have another reactivity series. We have potassium, sodium, calcium, magnesium, zinc, iron, tin, lead. You have to know the reactivity series because this carries the most crucial part of the chemistry. Yeah. But what you know is the most reactive is potassium and the least reactive is platinum. Metals compete for oxygen, for combined oxygen. A metal with high affinity for oxygen removes oxygen from the lower in the reactivity series. Less affinity for oxygen. When a metal gains oxygen, the process is called oxidation. Yeah, oxidation is whereby a metal acquires or gets oxygen. That's where oxidation comes in. For example, magnesium oxide. Magnesium plus oxygen to get magnesium oxide. Yeah, that's where oxidation has taken place. When a metal element donates or lose oxygen, the process is called reduction. Yeah. An element or compound that undergoes oxidation is called a reducing agent. Now, for instance, magnesium plus oxygen produces magnesium oxygen. Magnesium is the reducing agent. An element that undergoes reduction is called oxidizing agent. A reaction in which both oxidation and reduction takes place is called a redox reaction. Redox reaction between magnesium and copper. Okay, we'll wind there.